Hello everyone, and welcome back to another video. Today we're going to talk about RF3 Slope. So that's relations and functions, outcome number 3, all about slope. So the first thing that we need to do is really identify what the definition of slope is. So here we have a definition that says that the slope of a line segment on a coordinate grid is the measure of its rate of change. That doesn't mean a whole bunch to you guys right now. So really, as a working definition, what we can simplify this down to is the description of some sort of line that really just measures how many units that we're going up or down. So compared to how many units to the right that it moves. All right, so we'll use that as a working definition. Really nothing super mathematical about that, but you just want to be thinking, okay, as this line goes from left to right, how many units up or down is it moving? Okay, so let's dig into this a little bit more. Rate of change can be defined as your change in your dependent variable over your change in your independent variable. Now we know from earlier outcomes or even other courses like science that your dependent variable is going to be your y values and your independent variable is going to be all of your x values. Okay, so whatever we have along your y-axis over whatever you have along your x-axis. So again, we restate that as in a change in y over a change in x. Now, how do you measure that change in your y? So really what we're saying is we're going to compare two different y values. How does it change when you go from one to the other? And we're going to compare that as a ratio to the change in x. So we're going to look at how your x value changes from one to the other. Now we actually have a name for that change in both the x and the y values. And we have it defined as your y represents what we call the rise, and your change in x is what we call the run. So slope, or rate of change, is known as rise over run, or your change in y over your change in x, represented there at the bottom by delta y over delta x. And it's equal to y2 minus y1 over x2 minus x1. So that equation at the bottom might not make a lot of sense right now. So what we're going to do is we're going to look at a visual example to help us out. What we see here on the right-hand side, we'll see x1, y1, and we'll see an x2, y2. Those are really just points. Okay, so if we go ahead and write out the coordinates for both these points, here we'll have a -3 and a -2. And up here we have a +3 and a +3. So you've got 2 points there. And really what they represent are just your x1, y1, and your x2, y2. So at the bottom, x1 is represented by -3, and y1 is attached, or really is just a -2. For your second point on the top right, we've got x2 is 3, and y2 also happens to be 3. Now all we're doing is we can change, or we can compare the change in your y over your change in your x, otherwise known as your rise over run. So if we're looking up along your run here, or your rise rather, we're going to go ahead and see how many units we're moving up. So we move up 1, 2, 3, 4, 5 units up. And along your run, we're going to go 1, 2, 3, 4, 5, 6 units towards the right. So at this point, we can go ahead and state that your rise of this line is 5, and the run that we just figured out is equal to 6. In terms of your slope, we know that slope is equal to your rise over your run, and we can state it as your slope is therefore equal to 5 over 6. So essentially what we're describing is we're going to start off with x1, y1, and we're going to try to move over to x2, y2. What is the slope of the line that connects those 2 points? Well, to go from one to the other, we're going to take the x1, y1, so -3, -2. In order to get from there to our second point, we're going to have to move 5 units up. And then we're going to move 6 units to the right. Okay, so once again, if we're tracing along, we would have to move 5 units up this way and then 6 units that way. And that's how we'd come up with the slope of a line through those 2 points. Let's go ahead and try out a couple of examples here. So we're going to move from point A to point B, and then we're going to move from point C to point D. As we look along, and let's start off from point A, we're going to move upwards so that we get from A all the way to the same grid line that B is going to lie on. So we notice here we've gone up 6 units in total. And then as we move along, we're going to look at the run. So we're going to go all the way across, and we will notice that we've moved 10 units along there to the right. So because we're moving upwards, that means our rise is a positive 10, and our run, So because we moved up 6 units as our rise, our run is 10 units because we're moving 10 units in the positive x direction. So we know that our rise is right here, and this will be our run. So we can say that your slope is your rise over run, and we know that that's going to be 6 over 10. For those of you who are wondering, okay, can I reduce that or simplify? Absolutely. We can actually go on to say that slope is just really 3 over 5. Now, how does this help us out? Well, if we're starting back at A, and we know that your slope is 3 over 5, what this helps us do is we can actually find out another point on the line, and we're going to actually look for what we call a lattice point, which is going to be a point at the intersection of 2 grid lines. So points A and B are already lattice points because you can see that they're at the intersection of 2 grid lines. So we're going to look for another one here. So as we trace along from A, we're going to move up 3, okay, and move up 3, and then we're going to move 5 units here to the right, and we actually end up with a point there at -1, 0. If I were to continue to do the same thing, and we're going to move up 3, and we're going to move 5 to the right, you'll notice that we eventually end up at point B. So the slope allows us to find another point on the line that is a lattice point. We're going to try not to have too many decimal points. It makes things a little bit more complicated, especially if it's not a nice interval like a whole number or even 0.5. Okay, so your slope for that first example is 3 over 5. For example number 2, we're going to do the same thing. Let's start off at point C. We're going to trace downwards, and we're going to try to find the same grid line that D is on. So we're working from C. We're going to move all the way down here, and we'll notice here that our rise in this case is actually a -10. Now it's a -10 because we're moving in the negative y direction. Okay, so this is a rise of -10, and we'll take a look at the run. So in this case, we're moving 3 and then 5 units to the right. So our run is 5. So if we write this out, slope is equal to rise over run, and that's equal to -10 over 5. And we can actually simplify this to -2 over 1. Or we could even go further and say, or a -2. Now, just for us to start off with, it's much easier to see with a slope of -2 over 1 that for every 2 units that we move down, we're going to move 1 to the right. What I've noticed very often with students is if the slope is an integer, such as -2, they'll say that the rise is -2 and you'll have a run of 0, which is definitely not true. So that's why we are just going to stick with a fraction representation for now until we get the hang of things. So there are actually a few different characteristics of slope that we can point out here. The first one, when we're looking at the top left here, we'll see that your slope can be characterized as what we call a positive slope. That's because when we're moving from left to right, okay, as we're moving from left to right, your rise is going to be positive. That's the key there. As we're moving from left to right, your rise is positive. If there can be a positive slope, there can also be a negative slope. So your negative slope in this case is characterized by having a negative rise, which really just means that we're always moving in the negative y direction. So as we're moving from left to right, your line is going to be going downwards. Now the two at the bottom here are the tricky ones. We can have what is called a zero slope. And the reason why we have a zero slope is because we have a rise of 0. The line does not go up, nor does it go down, so our slope will end up being 0. We can also have the converse of that. We can also have something called an undefined slope. So what that means for us is rather than having a horizontal line, which gives us a 0 slope, we're going to end up with a vertical line. Now, how does that happen? We end up with a vertical line because we're going to have a run of 0. So that means that your line going from left to right, it doesn't actually move anywhere from left to right. It only moves up or it only moves down, leaving us with an undefined slope. The part that becomes undefined is because regardless of what rise we could have a rise of 4, we could have a rise of -10. Any number divided by a run of 0, so anything divided by 0, will always be undefined. So any vertical line segment has a slope that's undefined. So again, just to summarize in these discussion questions, why does a slope of 0 make a flat line, otherwise known as a horizontal line? Okay, there's a horizontal line because there is no rise. So your line does not go up or down. On the other hand, why does a vertical line have an undefined slope? In this case, we can say that there is no run. So rise over 0 is equal to undefined. So anything divided by 0 will always be undefined. So we'll have an undefined slope. Really key point. Make sure that you guys remember these characteristics. Very important when it comes to differentiating between a vertical line and a horizontal line. So far we've been talking about how to figure out a graph when you're given some sort of visual or graphical representation. Now what we're going to work through is seeing what happens if we're only given 2 points on a line. So here it says determine the slope of a line that passes through C, -5, -3, and D, which is 2, 1. The first thing that I'm going to do is rewrite the slope formula here in the middle. So we know that slope is equal to, and maybe I'll write this as well, we know that m is equal to slope, so that's just the variable that we have as a representation of slope. So we can say that m is equal to y2 minus y1 over x2 minus x1. Okay, so y2 minus y1 over x2 minus x1. So it's really a difference between your y values divided by a difference between your x values. So let's go ahead and label these. I'm going to go ahead and choose my C point, -5, -3, to represent my x1, y1, and point D to represent x2, y2. In case you've forgotten, in an ordered pair, it always goes x and then y. So your first number represents your x value, and your second number represents your y value. A question that you guys are probably thinking now is, how did I know that C would be my x1, y1, and how did I know that D would be my x2, y2? Well, I didn't know. I just happened to choose them to be that. And I'm going to go and work through it using this particular orientation first, and then after that, I'll flip them around and see if we end up with the same answer. Let's work through this and plug in those values. So I know that m is equal to y2 minus y1. So in this case, I have 1 minus a negative 3 divided by 2 minus a negative 5. So all I've done is I've plugged in my numbers into their respective slots there. So if I want to highlight this, I've said that I have y2. So y2 is right here, minus your y1, which is there, divided by your x2 over your x1. So note that I still keep those subtraction signs there. That's one of the key areas where people make mistakes, is they think because I have a negative 3 and a negative 5, I'm just going to go 1 minus 3. Well, keep in mind that the formula is y2 minus y1 regardless of what value you have there. So it's always y2 minus your y1 regardless if it's positive or negative. Let's simplify this a little bit. 1 minus a negative 3 gives me 1 plus 3, which is a positive 4. And 2 minus a negative 5 is the same thing as 2 plus 5, which means I have a positive 7. So my slope of this line is 4 over 7. And we know that a slope of 4 over 7 really just means that for every 4 points or 4 units we move up, we're going to move 7 units to the right. So going back to the question of how do I know which point will be my x1, y1, and which one will be my x2, y2? Let's imagine we flip those around. Okay, so we're going to take point D as my x1, y1, and C as my x2, y2. And we're going to just play around with it, see what happens. So we know once again that m is equal to y2 minus y1. We're going to flip them around this time. Negative 3 minus a positive 1 over a negative 5 minus a positive 2. We'll end up with negative 4 over negative 7. And what happens when we divide two negative numbers? Well, they both become positive. So you can see here, it doesn't really matter, okay, which order you put them in. We're still going to end up with the same slope. Question number 2, we're going to take points E and F. Let's label these as x1, y1, and x2, y2. So you've got m is equal to y2 minus y1 over x2 minus x1, as we can see there in the middle. So you've got 6 minus a negative 5. Let's clean that up. 6 minus a negative 5 over 8 minus 4. So 6 minus a negative 5 gives me a positive 11 because that gives us 6 plus 5. And 8 minus 4 just gives me a 4. So I've got my slope there. M is equal to 11 over 4. Again, if we were to interpret that, it means to go from one point to the other. To go from point E to point F, we'd have to move 11 units up and then 4 units to the right. On this page, we're going to do a little bit of extra practice. So let's start off by writing our slope formula on the right-hand side. So m is equal to y2 minus y1 over x2 minus x1. I'd recommend that you guys always start off with your formula first. I will just keep my formula on the right-hand side because I am going to run out of room on this page. So after we start off with that formula, let's go ahead and label our x1, y1 and x2, y2. So just through convention, I'm going to label the first one as x1, y1 and the second one as x2, y2. So you've got m is equal to 4 minus a negative 1 over your x2 minus x1. That's going to be 3 minus 2. This will give us m is equal to a positive 5 because 4 minus a negative 1 is 4 plus 1. And then 3 minus 2 gives me a 1. So I have a slope of 5 over 1, or 5. Question number 2, let's label these x1, y1, and x2, y2. This gives me m is equal to 7 minus 7 over negative 3 minus 0. That'll give me a 0 on top. So m is equal to 0 over negative 3. And we know that because we have 0 divided by anything is still going to be 0, we have a slope of 0, otherwise known as a horizontal line. So we have a horizontal line. We can see in this line that we have no rise because 7 minus 7 is 0, so we have a rise of 0. Next example, once again, x1, y1, x2, y2. We've got m is equal to y2 minus y1, so 6 minus a negative 5 over x2 minus x1, so 7 minus 2. This will leave me with a positive 11 up top, divided by 5. Your last example on this page. Once again, label your points, and then we'll plug them into our formula. M is equal to y2 minus y1, so negative 5 minus a negative 2 over your x2 minus x1, so 4 minus 4. This gives me m is equal to a negative 3 because we have negative 5 plus 2 divided by 4 minus 4, which is 0. Anything divided by 0 is undefined. So we have an undefined slope, which means that we have a vertical line. This next page requires us to use quite a bit of algebra. Again, let's write our slope formula up here in the top right. And this type of problem throws a bit of a wrench at us. We don't know everything about the 2 points. We're actually going to try to find out a value of k. So that could be the x or the y value of a specific point. So the first thing that we're going to do is label your x1, y1 and your x2, y2. So x1, y1 and your x2, y2. We're told that our slope is 4. So it's really important for us to get used to manipulating that slope formula that we have on the top right. We know that m is equal to y2 minus y1 over x2 minus x1. Since we know that slope is 4, we're going to say that 4 is equal to your y2, which is 7, minus y1, which is k, so 7 minus k, divided by your x2 minus x1, which is 4 minus 3. We can simplify that a little bit. 4 is equal to 7 minus k divided by 1, so that will stay the same. So we'll have 4 is equal to 7 minus k. I want to get the k by itself, so I'm going to subtract 7 from both sides. I'll get negative 3 is equal to negative k. Then I can divide both sides by negative 1 or multiply both sides by negative 1, doesn't matter. And I'll get a positive 3 is equal to k. So k is equal to positive 3. And we can check our answer by plugging that k value back into the original question there. If I plug a 3 into here, 7 minus 3 gives me a 4. 4 divided by 1 is equal to 4 that we have on the right-hand side. So we've done it properly. Second example says we have 2 points, 2, 3, and 8k, and m is now negative 2/3. Again, we're going to start off by labeling your x1, y1, and your x2, y2. We know that m is equal to negative 2/3, so we can say negative 2/3 is equal to y2 minus y1, which is k minus 3, divided by your x2 minus x1, which is 8 minus 2. Let's simplify this a little bit. The left-hand side stays the same, negative 2/3 is equal to k minus 3, and 8 minus 2 on the bottom can be simplified to just a 6. So we're going to cross multiply here to get rid of our denominators. So we'll do those two, and then we'll do these two. What that leaves us with is a negative 12 is equal to 3 times k minus 3. We need to distribute that 3 to both terms inside the brackets. So we end up with negative 12 is equal to 3k minus 9. We can add 9 to both sides. So negative 3 is equal to 3k. And finally, when we divide both sides by 3, we'll get negative 1 is equal to k, otherwise known as k is equal to negative 1. What I can do to check my answer is I can say, all right, we've got a negative 1 here. I'm going to plug that back into this k value. Let's go ahead and evaluate it. Negative 1 minus 3 gives me a negative 4. So let's write that down on the side. Negative 4 over 8 minus 2 gives me a positive 6. Well, that doesn't quite equal to negative 2/3. But wait, we can actually reduce that by factoring out a 2 from the top and the bottom. And that gives us a negative 2/3, which means that we've done this question properly. The last one here, we've got negative 1, negative 2, and we have k plus 1, where m is equal to 1/3. Well, this one's a bit tricky because now instead of having just one value of k, we have two of them pop up suddenly. Again, our process doesn't really change. We're going to start off with labeling everything as an x1, y1, and then x2, y2. We know that your m value is 1/3, so we'll start with that on your left-hand side. y2 minus y1 gives me a k plus 1 minus a negative 2, divided by x2 minus x1, which is k minus a negative 1. So I can simplify this and say that I have k plus 3 on the top, because I have 1 minus a negative 2 is the same thing as 1 plus 2. And then on the bottom, k minus negative 1 is the same thing as k plus 1. I need to cross multiply here again. So 1 times k plus 1 gives me a k plus 1. And 3 times k plus 3 means that I have 3 times a k plus 3. So let's go ahead and write that down. So I still have a k plus 1 on the left side because 1 times both of those terms is just, it leaves us with k plus 1. And then on the right-hand side, I have 3 times the k plus 3. I need to distribute that 3 to both terms inside of the brackets. So I have 3k plus 9 is equal to the left side as k plus 1. I need to move my k's to one side, so I'm going to subtract k from both sides. So subtract k and subtract k. I'll end up with 1 is equal to 2k plus 9. I'm going to subtract 9 now to get the k term by itself. And I'll end up with a negative 8 is equal to 2k. And then finally, I'll divide both sides by 2. So I'll get negative 4 is equal to k. So let's go ahead and check our answer. We're going to plug that negative 4 back into the original equation. So that negative 4 is going to come back all the way up here. Or really, we can put it into the second one, but let's just work with the original. So let's check. So 1/3 is equal to negative 4 plus 1 minus a negative 2, divided by a negative 4 minus a negative 1. Let's see what happens when we simplify a little bit. 1/3 is equal to negative 4 plus 1 minus a negative 2. So that's negative 4 plus 1 plus 2. That gives me a negative 1. On the bottom, I have negative 4 plus 1. Whenever we subtract a negative 1, it means we're adding 1. So negative 4 plus 1 gives me a negative 3. When we divide two negative numbers, we end up with a positive quotient or positive answer. So we have 1/3 is equal to 1/3. So we have solved for k correctly. The last part of today's lesson will be using slope to help us draw lines. So we'll take a look at this first example. We have a point here, point A, which happens to be at 4, 3. We want to be able to draw two lines through this point using two different slopes. So the first example here, we'll look to see what happens if we have a slope of 1/2. It means that your rise is 1 and your run is 2. So for every 1 unit we move up, we're going to move 2 units to the right. So I'm going to do this in red. So we're going to start off at point A. We're going to move 1 unit up and then 2 to the right, which gives us a point there. We're going to do the same thing, move 1 up, 2 to the right. We can't go any further to the right, so what I'm going to do is I'm going to start back at point A, and I'm going to do the opposite. Instead of moving 2 to the right, I'm going to now go 2 to the left. And instead of going 1 up, I'm going to go 1 down. 2 left, 1 down. 2 left, 1 down. 2 left, 1 down. What that allows me to do is I can plot a nice straight line through all of those points that I just put on the graph there. And this is a line with a slope of 1/2. So for every 1 unit we moved up, we moved 2 units to the right. Let's take a look at the second half of this example here. If we're given a slope that's negative, for example, let's say -2/3, I'm going to do this one in green. Let's start off again at point A. If our slope is -2/3, that means that for every 2 units we move down, we're going to move 3 units to the right. So we're going to go 2 down, 3 to the right, and gives us a point there. We can't move any further to the right, so we're going to start back at point A, and we're going to do the opposite. We're going to move 3 to the left, and then 2 up. 3 to the left, and then 2 up. And we can plot, or we can draw a nice straight line through those 4 points there. So as long as we know the slope of a line and we have a point to start with, it's relatively simple for us to draw a line through that point. Let's do a couple more practice problems here. We're going to start off with 0.21, and we're going to have a slope of 2/5. So 2, 1 would be somewhere right about here. So a slope of 2/5 implies that for every 2 that we'd move up, we'd have to move 5 to the right. So we can see that if we move 2 up and we try to go 5 to the right, we're going to run out of room. So we're going to start back at this point, and we're going to do the opposite. We're going to move 2 down, and then we're going to go 5 to the left, and to have a point right there. We can't go any further to the left, so I'm going to draw a line through the 2 points that I made, and we've got our first line there. Let's take a look at the second one, line B. So we have -4, 5, and we are going to have a slope of -4/3. So -4, 5 means that we're going to look at a point right here, and a slope of -4/3 means that for every 4 that we move down, we're going to move 3 units to the right. We're going to do the same thing. We're going to move 4 down. So 1, 2, 3, 4, and then 3 to the right. Since I can go no further, let's go and draw a line through those points. And we have our second line on this page. Point C, we can see that we've got a starting point of 0, -4, and we have a slope of +4. So let's go ahead and plot our first point. So 0, -4 is right there, and we have a slope of 4. So that slope of 4 really just means that we have a slope of 4/1. So for every 4 units we move up, we're going to move 1 unit to the right. So we're going to move 4 up. So 1, 2, 3, 4, and then 1 to the right. 4 up, 1, 2, 3, 4, and then 1 to the right. And then I can draw a nice straight line through those points there. Line D has us starting off at 5, -3. And now we have a slope of 0. So this slope of 0 really just means that we're going to have a horizontal line. So this horizontal line is really just going to move across that grid line like so. So we have our line D moving through that point. Last but not least, we've got an undefined slope moving through point -2, -1. So -2, -1 is right here. And we are going to draw a vertical line because an undefined slope is a line that is vertical. And we're going to go ahead and draw that vertical line through this point here. And we have point E, or line E rather. Last couple of examples we'll try out today. Here it asks us to draw a line segment with each given slope. So we have essentially free reign to pick our starting point. So a slope of 7/5 means that for every 7 units we move up, we're going to move 5 units to the right. So let's start off somewhere in the bottom left so we have enough room to move up and to the right. So let's start perhaps here. We're going to move 7 units up. So 1, 2, 3, 4, 5, 6, 7. And then we're going to move 5 units to the right. 1, 2, 3, 4, 5. So we'll get a point right there, and we can connect those points with a straight line. So this would be a line with a slope of 7/5. Again, we're not too concerned about the starting point. We just want some sort of line segment with that given slope. So it could look something like that. Next, we're going to take the green, and we have a slope of -3/8. So for every 3 units we move down, we're going to move 8 units to the right. So let's start somewhere up here so we have enough room to move down and to the right. So we're going to move 3 units down and then 8 units to the right. So 1, 2, 3, 4, 5, 6, 7, 8 will leave us with a point right there. And we can once again connect those 2 points with a nice straight line. Now, a question that's going to be asked quite often, -3 like this over 8. Then we're going to have 3 over a -8. And then we're going to have a negative right there. And it looks like that negative only applies to that line in the middle there. So -3/8. How do I know which one is which? Which one should I use in this case? Well, mathematically speaking, all 3 of those are equivalent. -3/8 is the same thing as 3 over -8, or just a -3/8 in general. All 3 are mathematically equivalent, but which one makes the most sense to us? So in this case, we've been looking at the slope of a line moving from the left to the right. So usually the run is going to be positive. And if we have our rise be positive or negative, it tells us if our slope is going to be positive or negative. So the one that actually makes the most sense for us to use and to understand is going to be that first one, having a negative on the numerator. Your top number there will make the most sense because we can automatically see that we're going to have a negative rise, which means that your line is going to start to go down. It's not incorrect to use the other 2, but if we were to look at that second one there, 3 over -8, it would really just look like we're going backwards. It would just mean that for every 3 units that we move up, we're going to move 8 units to the left. So let's say, for example, let's look at that first one, -3/8. If we're starting here, and let's call that point A, and then we're going to call this point B. To go from A to B, we'd have to move 3 units down and 8 to the right, because that's what our slope is telling us. If we looked at this as 3 over -8, we'd actually be going from point B to point A. So if we're going left to right, we definitely want to be looking at this. If you want to move from B to A, let's say you started off here and you wanted to know that a slope of, or what would happen if you had a slope of -3/8, well, you can't really go to the right any further. We'd run out of room. So we'd have to move to the left by looking at this second portion there. Okay, so again, mathematically equivalent, but this first interpretation is generally the one that's more useful for us in this particular outcome. Let's try out 2 more here. I've got 4/9 as our slope. So again, let's start in the bottom left here somewhere. So let's start off there. 4/9 means that we have for every 4 that we move up, we're going to move 9 units to the right. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right. And again, we can connect our line segment there with a straight line. Lastly, we're going to take a look at this one, -8/3. Let's see what happens in this case. We would know that this slope is telling us that for every 8 units we move down, we're going to move 3 units to the right. So let's start up here and see where we end up. So if you start off there, we're going to move 8 units down. 1, 2, 3, 4, 5, 6, 7, 8, and then 3 units to the right. So we'll end up with a point there, and we can go ahead and connect those 2 points with a nice straight line. And essentially that finishes our lesson for today. So again, some of the things that we talked about: what is slope? How do we figure out the slope of a line if we are given a graphical representation? And then how do we figure it out if we are given 2 points, as well as how do we draw a line if we're given the slope of the line as well as a point on the line. In the next lesson, we're going to look at slope as a rate of change, and then we're also going to look at what makes 2 lines either parallel lines or perpendicular lines. Until then, I'll see you guys in the next video.